Hello students, welcome to CATCH25 Academy. Let us continue our discussion of Newton's laws of motion with friction. So we are continuing with question number 14 of our illustrative examples. So in question 14 we have three masses. So three masses are as shown in the diagram. They are kept on a horizontal surface, which I am showing in green color. The masses are 2m, m, and 2m. There is a force which is applied on this mass, capital F. So this is mass A, B, and C. Now, in this case, the friction is given as mu. So in this case, we need to find the minimum value of F so as to prevent block B from sliding. So let us see how to solve this question. Now, in this case, we have the acceleration A. We will come out to the total force F upon 2m plus m plus 2m. So total force is F on the system upon 2m plus m plus 2m, which is F upon phi m. So this is the acceleration. Now, in this case, the normal reaction N, that will be equal to, in this case, we are trying to find the normal reaction on one block. So let us consider three body diagram of each block. So this is 2m. We have a force F and normal reaction N by block of mass small m on capital 2m. So N1. Then we have next block, which is M. N1 normal reaction from this side, N2 normal reaction from this side. Then we have rightmost 2m, N2 normal reaction from this side. Acceleration A, acceleration A, acceleration A. For all the three blocks, we have same acceleration A. Now, if I consider Newton's law equation for this block, N2, this will be equal to 2m into A. So which is 2m into acceleration value is nothing but F by phi m. So our acceleration normal reaction value will come out to be 2 by phi into F. So this is the value of normal reaction N2. Now, if we consider the friction, so we can say friction force on this block will act in vertically upward direction and mg will act in downward direction. So friction value for this block is equal to mg. So friction, we can say, has to be greater than mg, in fact. So friction, which is mu n, has to be greater than mg. So this is mu n2. So mu n2 has to be greater than mg for the block not to fall down. So mu into n2 value is 2 by phi f. This has to be greater than mg for the block to not fall down. So f has to be greater than or equal to phi by 2 mu into mg. So our answer to this question will be this. Force minimum value is phi by 2 mu into mg, which corresponds to option B. So the correct answer in this case is option B. Now, let us move on to next question, which is question number 15. So in question number 15, we have a horizontal force sufficient to move rough horizontal plane. So let us first consider a body. Let us place this body on a rough horizontal surface. Now, a horizontal force, let us say F, is sufficient to move this body of mass 4 kg. So let us consider body of mass 4 kg. mu s, it is given to us as 0.8, mu k is 0.6. Now it is given if the force continues to act even after the block starts moving. So this force F continues even after the block starts moving. So in this case, we can say now that force F continues to act even after the block starts moving. So we have to find the acceleration of the block. So let us first see how much is the value to just start the block. So in that case, force applied should be equal to friction force, which is mu mg, mu into n, which is mu into mg. So in that case, we can say force required or applied to just move the block. This is mu, which is given to us in this case as 0.8. Mu is mu s, which is 0.8 into mass is 4 into g is 10, let us say. So 32 Newton is the force. And kinetic friction, mu k into n, which is mu k into mg, which is 0.6 into 4 into 10. So this comes out to be 24 Newton. So kinetic friction is 24 Newton. Now once the block starts moving, we will have only kinetic friction. So this is the block. It has a mass of 4 kg. The applied force is 32 Newton and the kinetic friction in backward direction, it will be 24 Newton. So acceleration we can calculate. So let us do big force minus small force is equal to mass into acceleration. So big force in this case is, so in this case we have the big force value, which is 32 minus 24 is equal to 4 into a. So 8 is equal to 4a, giving the value of acceleration a as 2 meter per second square. So the answer to this question is acceleration is option C, 2 meter per second square. Moving on to our next question. So question number 16. In it we have two blocks as shown in the diagram. This is block number 1 and this is block number 2. So we have two blocks, A and B. They are connected by a string. So this is the connecting part between two blocks. The horizontal is like this, and this geometry which we are given here is like this. So this is 8, this is 15, and we can find the third side. So this is block A, this is block B. Both have same mass, which is 170 kg. Mu A, it is mentioned to us as 0.2. Mu B is 0.4. In this case, we have to find the force developed in the bar. So let us find the tension force kind of force. So let us see how to solve this. So in this case, if I call this angle as theta, then I can tell cos theta. So if we can find this by the triangle. So if this is 15, this is 8. So in this triangle, the third side has to be root of 15 square plus 8 square, 225 plus 64, which is 17. So this is theta, this is 8, this is 15. So cos theta in this triangle, we can find out as adjacent upon hypotenuse. So 15 upon 17. Sin theta is opposite upon hypotenuse, which is 8 by 7. Now, if I consider this force, which is mg sin theta minus friction force. So we will have friction force here, and there will be a tension force, and there will be acceleration. So mg sin theta minus friction force minus tension is equal to mass into acceleration. So mg sin theta minus mu mg cos theta minus tension is equal to Ma. Now, let us substitute the values and find the value of tension force. So M is 170, G is 10, sine theta is 8 by 17 minus mu for block A is 0.2 into M for block A is 170, G is 10, cos theta is 15 by 17 minus T is equal to M, which is 170 into acceleration. So this is how we'll have an equation. So let us call this equation, simplifying, we'll get the equation for this block A. So upon simplification, 170 cancels on both sides. 170 is the mass which cancels, and we will get a new equation, and it will be 500 minus T is equal to 170A. So this is our first equation. Let us call it equation number 1. So this is equation number 1. Now, after this, let us consider block B. So for block B, we have tension force T in downward direction. Mg sine theta is also in downward direction. Friction is in upward direction. So we can say T plus mg sine theta minus friction on block B is mass of block B into acceleration A. So T plus M, which is 170, into G, which is 10, sine theta, which is 8 by 17, minus friction on B, which is mu mg cos theta. So mu, which is 0.4, into M, which is 170, into G, which is 10, into cos theta, which is 15 by 17. That equals mass into acceleration, which is 170 into A. So on simplification, the equation which we'll get is T plus 200 is equal to 170A. So this is the equation for block B. Now, once we get two equations, equation 1 and equation 2, we can solve these two equations for value of tension and acceleration A. So in this question, we have to calculate the value of tension. So on calculating, if I take these two equations and simplify LHS, if I consider 500 minus T is T plus 200. So that gives us 2T equals 300. So T comes out to be 150. So tension force is 150 Newton. So the correct answer to this question is 150 Newton, which corresponds to option A. So the answer for question 16 is option A, 150 Newton. Next, let us move on to next question, which is question number 17. Now, in question 17, we have a table. So let us first draw the diagram. So in this case, we have a table, and on the table, we keep a block. The block has a mass of 2 kg. So in this case, the coefficient of friction is 0.4. The applied force is 2.5 Newton, which is in rightward direction. We have to find the value of friction force in this case. So let us see how to solve this question. In this case, we are given friction force, we have to calculate. Applied force is 2.5 Newton, and we have to calculate the value of friction force. So let us see how to solve question 17. So friction has formula mu n. It is value of friction, maximum value of static friction in this case. So mu is 0.4, n is mg. So 0.4 into 2 into 10. So that will be the value. The value on calculating will be 8 Newton. So we have static friction maximum value, which is 8 Newton, and 8 Newton is the static friction which acts in backward direction. So that is the maximum value of static friction, Fs max. But the applied force is 2.5 Newton. The applied force in this case is less than maximum value of static friction. So we can say acceleration will be 0. So from that, we can say the friction in this case is static and it is less than limiting value. The answer is 2.5 Newton, which corresponds to option A. So the correct answer to 17th question is option A. Next, let us move to question number 19. So in question 19, we have a diagram in which we have a block, and we have in this case we have a block which is kept on a table, and the mass of the block is given as in this case root 3 kg. So in question 18, we have two blocks. So one is block A and another is block B. So let us consider this as my block B and another block placed on this as block A. Now, in this case, we are applying a force capital F on block B. And in this case, we have a wall on the other side. So let me show this, the wall. Now, there is a string. Let us say I show the string in red color, which is attached to block A as shown in the diagram. So this is the string which we have. Now, in this case, block A, it is having a mass of 100 kg. Block B, it is having a mass of 200 kg. Now, the coefficient of friction between A and B is 0.2, while the coefficient of friction between ground and B is 0.3. We have to find the minimum value of force to start moving B. So we have to move B. So in this case, let us see the diagram. Let us see the direction of friction. The friction on A will be in backward direction. Let us show friction in backward direction on block A. Let us call it FA. The friction on block B will be in forward direction on its upper surface. Let us call it FA itself because it is action reaction pair. And we have a friction FB on block B. So these are the forces in horizontal direction. So in this case, I can say the total force on block B. If we draw the free body diagram of block B, it will be like this. One force is in right direction, another force is in left direction, and one more force is in left direction. So the forces are capital F, small f A, small f B. Now, in this case, we have total force F on B, that is equal to friction of AB, which is FA, plus friction of B ground, which is FB. Now the value of total force F on B will be mu A into MA into G plus mu B into MA plus MB into G. So this is the equation. So in this case, the value of FB will be mu B into MA plus MB into G. So force of B, mu A, its value is 0.2, MA, which is 100, G, which is 10, plus mu B, which is 0.3 into 100 plus 200 into G, which is 10. So FB, the applied force on calculation, it will come out to be 1100 Newton. So the correct answer is option C for question 18, which is 1100 Newton. Now, let us move on to question number 19. In question number 19, we have a block which is placed on ground, and in this case, the mass of the block, it is given to us as root 3 kg. Now, we are applying a force as shown in the diagram. It is at some angle with the horizontal. So suppose this is the horizontal. So this angle here is 60 degree. So we can take the components of this. So in this case, let us consider the components. So the horizontal component and vertical component. These are the two components. So in this case, I can think horizontal component will be, this angle will also be 60. So this is F cos 60. This is F sin 60. Also this root 3g acts in downward direction. Normal reaction acts in upward direction. We have to find the minimum value of F so that there is no motion. So we can say F cos 60 should be equal to maximum value of static friction. So mu S into N is F cos 60. Cos 60 is half, and in this case, we have vertical force balance equation as upward force is equal to downward force. So downward force in this case is root 3g plus F sin 60, Upward force in this case is normal reaction. So N is root 3g plus F root 3 by 2. So this is the value of normal reaction N, which we'll use in later equation. So mu S, in this case, mu S into N, which is root 3g plus F root 3 by 2. Now, from this, I'll calculate the value of F, but mu S, let us substitute as 1 by 2 root 3. So mu S is given as 1 by 2 root 3. So on doing these calculations, we'll find that question 19, the force applied will come out to be 20 Newton. So the minimum force is 20 Newton. So the correct answer here is option A. Why? Because root 3 will cancel. 10 upon 2 is 5. 5 plus F into, in this case, we will have F by 4. So in this case, 5 plus F by 4, that will be the value. Now, F by 2 minus F by 4, if I take F common, so F by 4 is equal to 5, so F comes out to be 20 Newton. That is the calculation. Oral calculation we can do easily. Next, let us move on to question number 20. In question number 20, we have a block which is having a mass of M and it is kept on a horizontal surface as shown in the diagram. There is a force which is applied at some angle, which is mg is equal to F. The magnitude of force is mg and it makes an angle theta. The coefficient of friction is mentioned as mu. Let us consider the forces, horizontal component of this force and vertical component of this force. So this will be F cos theta, this will be F sin theta, and we will have normal reaction in upward direction. Finally, the friction force will be in backward direction. So let us see how to solve this question. Along vertical direction, upward force is downward force. So N plus F cos theta equals mg along vertical direction, which gives us N equal to mg minus F cos theta. So N value will be mg minus F cos theta. So this is the value of normal reaction. Now, after this, if I consider friction force F sin theta along horizontal, this rightward component should be just greater than or equal to maximum value of friction, which is mu n. So F sin theta must be greater than or equal to mu into mg minus F cos theta. So from this, we can find the value. So in this case, let us substitute F as mg according to the given question. Capital F is mg. So mg sin theta greater than or equal to mg minus mg cos theta into mu. So mg cancels everywhere. We get sin theta should be greater than or equal to mu into 1 minus cos theta. So from this equation, I can get the value of mu. So how will I get? So we can use double angle formula. So this is 2 sin by theta by 2 cos theta by 2. This is greater than or equal to mu into 1 minus cos 2 theta is 2 sin square theta by 2. So sin 2 theta cancel, 2 cancel. We get cot of theta by 2 is greater than or equal to mu. So the correct answer to this question is option D, cot theta by 2 greater than or equal to mu. Now, let us move on to next question, which is question number 21. In question number 21, we are given a body of mass 10 kg, which is lying on a horizontal rough surface. So we have an inclined plane. The angle of incline is 30 degree as per the given question. And there is a body of mass 10 kg, which is lying on this inclined plane. The coefficient of friction is mentioned as 0.5. In this case, we have to find the minimum required pull force to take the body up the incline. So let us consider the forces. In this case, we have to find this force capital F. We have other forces like mg, which is 10g. Its component here will be 10g cos 30 and 10g sin 30, as we have done in Newton's laws of motion many times. We have normal reaction N perpendicular to the incline, and we will have the value of friction, which is mu n, which will be down the incline because the motion is up the incline. So in this case, we have F is equal to small f plus 10g sine 30, because up the incline force equals down the incline force. Now, let us substitute the value of F, friction force, as mu n. So mu is 0.5 into n is 10g cos 30 plus 10g sine 30 as it is. So the value of applied force will be 0.5 into 10 into g is 10. Cos 30 is root 3 by 2 plus 10 into 10 into half. So from this, we have 25 root 3 plus 50. This is the value of applied force. So on calculation, we'll get 25 into 1.73 plus 50. So let us try to find the value of this force. So let us approximate this 1.73 as 1.7. So 25 into 1.7, we have to find out. So 35, 20, 14. So this is 17. And we have 5 and 2 here. So this will be 4.25, 42.5. So this is 42.5 plus 50, which almost comes out to be near 92. So this, our answer should be almost 92. So the correct answer to this question is option B, 91.4 Newton. Now, moving on to next question, which is question number 22. We have a block which is placed. So consider this as a block which is having mass 4 kg. It is placed on a top of a 8 kg block. So we have another block in this case whose mass is 8 kg as shown in the diagram. And these both block system is placed on a horizontal ground as shown. Now, in this case, we are given A just slips on B when a force of 12 Newton is applied to A. So that is block A and block B. If I apply 12 Newton force, A just slips. So in this case, we have to find maximum force on B. So we have to calculate the value of force on B so that they move together. So we want these two blocks to move together. So in that case, because they move together, let us consider acceleration as total force upon total mass. Total force is F in this case upon total mass will be in this case 4 plus 8 kg, which is 12. So we can say acceleration of both blocks if they move together is F by 12. Now for block A, if I consider for block A, we have only one force, which is friction force, which can act in forward direction. So friction force is equal to mass of block A into acceleration. So friction in this case, maximum value is 12, which is mass of block A 4 into F by 12. So the value of capital F comes out to be 144 upon 4, which is 72 upon 2, which is 36 Newton. So the correct answer in this case will come out to be 36 Newton. So we have done what in this case? We have in this case 12. Okay, we have one more force which is 12 Newton which acts on it. So let us consider this force as well. So if I consider this force, then friction will be in backward direction. So block A friction will be in backward direction. So friction, let me consider backward direction. It is small f. And forward direction we have 12 Newton. So in this case, we will have equation which is, in this case, let us consider the friction force. So what are we needed to find in this question? Maximum horizontal force on B to make both blocks move together. So for both blocks to move together, we should have friction. So friction on block A is 12 in forward direction. So 12 is 4 into acceleration, which is F by 12. So applied force has to be 36 Newton. So in this case, the correct answer to this question will be 36 Newton, option C. Then moving on to next question, which is question 23. In this case, we have one block and another block, two blocks placed on top of each other and ground at the bottom as shown again. Block A on top, block B on bottom. Applied force is 0.15 Newton in forward direction. Now, in this case, block A has mass 1 kg, block B has mass 0.2 kg. In this case, we have coefficient of friction between A and B. It is 0.15. We have to get B will slide on A if force on A is greater than. So in this case, we have to find B will slide on A. So let us first think about the forces. So block A, one force is N1, another force is 1G in downward direction. For block B, we have N2 force by ground on block B, MBG. Here we have MAG, here we have MBG. And normal reaction N1 in downward direction. Then, in this case, we also have a horizontal force F, which is 0.15 Newton on blocking. Now, from this diagram, I can say N1 is 1G, which is 10 Newton, and static friction maximum value. Mu s N1 on calculation comes out to be 0.15. So in this case, we have given the value 23 question, we have 0.2. The friction value is 0.2, sorry. So friction value is 0.2. So I have to write here 0.2 into N1. N1 is 10. So 2 Newton. So the maximum value of static friction comes out to be 2 Newton. Now, based on this, let us do the calculations. But in the given question, we are given A is resting on a smooth surface. So we can take friction here as 0. So in that case, how will we solve this question? So we'll consider mu as 0.2 for this side. Here mu is 2. A is resting on smooth surface. So mu is 0 here and 0.2 between B and ground. So in that case, we can say for block B, we'll have first of all static friction maximum value is mu s into N, which is 0.2 into MA plus MB, which is 1 plus 0.2 into G, which is 10. So on calculation, we will get this as maximum value of friction. So 1.2 G Newton. So N comes out to be 1.2 G. So in this case, we have mu s, which is given to us as 0.15. Mu s is 0.15. So 0.15 into 1.2 into G. This is 1.8 Newton. So the applied force is 1.8 Newton. So the closest option is 1.674 Newton, which is option A, which is the correct answer to this question. Now, let us move on to next question, which is question 24. In question 24, we are given a diagram like this. We have two blocks A and B. A has mass 2 kg and B has mass 8 kg. Now, in this case, we are given coefficient of friction between A and B 0.2, while that floor and B is 0.5. When a horizontal force is applied on block B, F, which is 25 Newton, the force of friction between A and B we have to calculate. So let us first draw the free body diagram of A and then of B. So in A diagram and B diagram, we have mg force in vertically downward direction. We will also have normal reaction N1 and normal reaction N2 as well as N1 as shown in the diagrams. Then we have friction forces. So friction on 2 kg block will be in forward direction F1, let us say, and here we will have reaction force F1. Now F1 value is mu N1, mu1 into N1. Then N1 value is 20 Newton, which is N1 in this case is 20, which is 2 into G. And here we will have F2 friction as well in backward direction. Now, in this case, I want to find the value of friction between A and B. That means F1. So F1 will be mu1, which is 0.2 into 20. 0.2 into 20, which is 2 by 10 into 20. So this comes out to be 4 Newton. So in this case, we have 4 Newton friction in question number 24. So 3.9. So the closest option will be 3.9. So in this case, question 24, let us find the value of friction. So now in this case, if I find the value of N2, it will be nothing but 10G, which is 100 Newton. So F2, friction on block 2, this will be mu2 into N2. So mu2 is 0.5 into N2 is 100. So friction here will be 50 Newton. So F2 value is 50 Newton. F1 maximum value of friction, static friction, if at all, it will come out to be 4 Newton. So let us now think. We have 25 Newton in horizontal direction on block B. 50 Newton is the static friction. So will in that case block B move? No, there will be no motion of block B. Because there is no motion of block B, we can say in this case block B is at rest and block A is also at rest. So friction on block A will be 0. So friction between block A and block B will come out to be 0 because there is no motion of block B. Then 25th question. So in 25th question, we are given a diagram like this. So we have one mass, another mass here. So two masses we have. One mass is kept on table like this, and these are the legs of the table. One leg of the table here and another leg of the table here. Then we have a pulley as shown in the diagram. So this is our pulley. Now, this pulley is connected by a string, let us say in yellow color, which I am showing here. And this string is further connected to mass as shown. Now, M1 is the lower mass, M2 is the upper mass. So the M1 is lower mass, M2 is mass on table. This is 20 kg and lower mass is 4 kg. In this case, we have coefficient of kinetic friction 0.03. We have to find the acceleration of the block. So let us draw the diagram. Here we have 4G force, tension force here, and friction force in backward direction M2G, normal reaction N. Maximum value of static friction in this case is mu Sn. So mu S is 0.03 according to question. Into normal reaction is M2G. M2 value is 20. So 0.03 into 20 into 10. So this comes out to be, in this case, 0.3 and 3. So 6 Newton. So maximum value of static friction comes out to be 6 Newton. Now, if at all there is acceleration, it will be in downward direction and this will move in forward direction. So in that case, for this block, we have 4G minus T is 4A. And for this block along horizontal direction, we have T minus friction force is equal to 20A. Now, if I want to find the value of acceleration, is there any acceleration or no? So what I'll do is add these two equations. So 4G minus F is 24A. Friction maximum value, if I substitute it is 6 Newton is equal to 24A. So 34 is equal to 24a, which gives us a acceleration as 34 upon 24, which is 17 upon 12. Now 17 upon 12 is 1 point, in this case we are 4, 1.4. So acceleration comes out to be 1.4. So in this case, we can say the correct answer is option C, which is 1.4 meter per second square. So the 25th question correct option is option C as shown.